All right, let's just jump right in. We're about to tackle one of the most famous and, one of the weirdest thought experiments in all of science. It's all about a cat, a box, and, well, the very nature of reality. And this is the question, the really mind-bending one at the heart of the whole thing. It was first asked almost 90 years ago, way back in 1935, by the physicist Erwin Schrödinger. Now, he wasn't talking about a real cat, of course. He was trying to point out a huge, glaring problem right at the center of quantum mechanics. So to really wrap our heads around this, we've got to set the scene first, and I want you to think of it like a quantum crime scene. Yeah, a crime scene where the victim might also be the survivor, and where the normal laws of physics just kind of seem to go out the window. Okay, and here's what's so clever about this whole setup. It perfectly connects two totally different worlds. On one hand, you've got this tiny, random, microscopic event, just a single atom decaying, which is ruled by the super weird laws of quantum mechanics. But then, that tiny event is directly linked, chained really, to a massive, real-world outcome, whether a cat lives or dies. And this is where the paradox really hits. See, according to quantum theory, for as long as that box stays closed, the atom is in what's called a superposition. It's basically in a fog of all possibilities. It has both decayed and not decayed, all at once. And since the cat's fate is tied directly to that atom, they're what physicists call entangled, the theory says the cat is also in a superposition. It's simultaneously alive and dead.
So you might be thinking, why on earth would Schrödinger come up with such a crazy-sounding scenario? Well, he did it for a very specific reason, to shine a big, bright spotlight on a huge, unsolved problem in physics, a mystery that we call the measurement problem.
Let's unpack that a little. You see, down in the quantum world, everything is just, well, it's all about probabilities. Before we actually go and look at something, an atom could be spinning up and down at the same time, or it could be in two places at once. It's just a haze of potential realities, all existing together. But then, the moment we measure it, the second we look, that whole cloud of possibilities just collapses into one single definite outcome. Poof. The atom is now either decayed or it's not. The cat is either alive or it's dead. It seems like our very act of looking forces the universe to pick a side. And that, right there, leads us to the core question. What is it about a measurement that makes everything snap into place? Is it a person looking, a machine, or is it just any old interaction with the bigger world? Nobody knows for sure. And that is the fundamental mystery. It's this blurry, unexplained line between the fuzzy quantum world and the solid, concrete reality we all live in. Now, over the years, physicists have come up with a bunch of different theories trying to solve this thing. So let's play detective for a minute and investigate the two main suspects, the two most famous ideas about what's really going on inside that box. First up, you've got the classic Copenhagen interpretation. This one says the observer is the key. The moment you open that box, your act of measuring forces reality to pick one path. Boom, the superposition collapses. But then there's the many worlds interpretation, which is honestly a much wilder idea. It says there's no collapse at all. Instead, every single time there's a quantum choice to be made, the entire universe splits in two. So in one universe, the cat lives, and in another, totally separate, parallel universe, it dies. Both things actually happen. And you can see how this just shows how deep the problem really is, right? We're not just talking about the limits of our instruments here. We're forced to think about the very nature of existence itself. It makes you ask, what does it even mean to observe something? And could reality itself actually depend on whether or not we're looking at it? Okay, but those are kind of the old classic theories. Recently, a brand new lead has popped up, a totally different tactic. And it begs the question, what if we'd been investigating this quantum crime scene all wrong? What if we don't actually have to kick the door in to figure out what's going on? So here's the big idea. What if you could actually gather clues about what's happening inside the box, but without making a direct measurement that destroys the whole quantum state? Instead of barging in and forcing an outcome, what if you could just peek inside, really gently? This new approach suggests we use a sort of quantum detective, a single particle that doesn't interact very much, something like a neutron. The plan would be to send it right through the box, let it have a very, very gentle interaction with whatever's inside, and then see what kind of information it's carrying when it comes out the other side. All right, so how would that actually work in practice? Let's follow our little neutron detective and see how it could crack the case without, messing up all the evidence.
So here's the setup. You fire a single neutron at the box. It just sails right on through. And while it's inside, it interacts just a tiny, tiny bit with the cat system. And that's whether the system is in the alive state, the dead state, or that weird superposition of both. And then it just pops out the other side. And this is the smoking gun, right here. That little interaction leaves a tiny imprint on the neutron. It's a property called a phase shift. The best way to think about it is like a ripple in a pond. The shape of the ripple tells you what kind of stone you threw in. And what's so crucial here is that this quantum ripple looks different depending on whether the cat is alive or dead. So our little neutron detective comes out carrying a clue.
Okay, now this formula looks super complicated, I know, but don't get bogged down in the math. Here's all you really need to know. This equation gives us a way to decode the clue that our neutron detective brought out. Specifically, that last little piece of it, that cosine term, that is the smoking gun. It's a unique mathematical signature that can only show up if the cat is still in that bizarre quantum superposition of being both alive and dead.
So what does this all mean? It means that by shooting lots and lots of neutrons through the box and measuring the pattern they make on the other side, we could look for that special signature. We could, in theory, see the superposition itself or prove that it has collapsed, all without ever opening the box. We'd basically be gathering quantum evidence from the outside.
And this brings us to one last really mind-bending thought. This whole approach doesn't just give us a new tool to investigate the paradox. It actually makes the mystery even deeper. Because if we can get information about a quantum system without causing the collapse that we always thought came with observation, then what does it really mean to measure something? What does it even mean to know something? It kind of suggests that the line between what we know and what is real is way, way blurrier than we ever thought.